All right, so today we're going to look at multiplying fractions. And we want to start with an example because I want to use a picture because I want you all to see why we're doing what we do. I think that's so important that you understand why you're doing what you do in math, because otherwise it makes no sense and you're just memorizing things. So we've got 1/2 times 1/4. And so times has a special meaning in math, and I think you guys probably already know this. It means the word of. So I'm going to look at 1/2 of a 4th. And I've got a picture over here, and I've got, we could call it a candy bar and say that we've got a 1/4 of it. So there's a 1/4. And you're going to take that 1/4 and you're going to share 1/2 of it with somebody. Well, how much is that? Well, if I cut this in half, and let's do this on your paper. When you cut it in half, there's 1/2 right here. Well, how much is that out of the whole candy bar? Well, when we cut it in half, if we cut them all in half, all the pieces, or what would be pieces, then we have 8 pieces. So technically, 1/2 of this 1/4 is the same thing as 1/8. So over here, when we do 1/2 of a 4th, we're going to multiply, and we multiply the numerator straight across, and 1 times 1 over, and then we're going to do 2 times 4. And we do that, we get 1 times 1 is 1, 2 times 4 is 8. Now, you're probably going to ask, why are you putting this step in, Miss Stevens? Well, right now you don't really need it. You can just say 1 times 1 is 1, 2 times 4 is 8, and go straight there. And that's okay. But we're going to do some examples in just a minute where we're going to see that these are factors, and we're going to do something with common factors before you actually multiply them through. So now let's look at example 2. In example 2, we've got 3/4 of -1/2. Now, we've already been working with integers and knowing that we've got positive and negative integers. Well, we also have positive and negative fractions. So you have to go back to the rules, and the rules say that if you have a positive times a negative, that is going to be equal to a negative. Now, before we actually get the answer, I'm going to just put over here that we know our answer is going to be negative . But let's come back over here, and we're going to do this one the same way we did this one above, and we're going to show the factors. So I'm going to take 3 times, and I'm going to move that negative up to the 1 and say that this is the same thing as -1 over 2. I could have also moved it to the denominator, but I'm just going to move it to the numerator. So we're actually saying 3 times -1 over 4 times 2. Now when we multiply straight across, we can say 3 times -1 is -3, and 4 times 2 is 8. So our answer is -3/8. And I'm sure you're thinking again, well, Miss Stevens, I could have just said positive times negative. My answer is going to be negative. And then 3 times 1 is 3, 4 times 2 is 8. And you're exactly right. Okay, but now let's look at another example where we're going to do something with those common factors. So now we're on example 3, and we're going to multiply 1 times 4, the numerators, and we're going to multiply the denominators 4 times 5. Now, do you see a common factor in the numerator and denominator? I hope you say, oh yeah, I see that. Okay, now before we actually cancel, I want to look at something because I want you to understand. I can take this multiplication and I can change the order. I could say that's 4 times 1 or 1 times 4. So I'm going to change it to 4 times 1. That's called the commutative property of multiplication. If you're multiplying, it doesn't matter what order you do it in, you'll get the same answer. And I'm going to keep this one 4 times 5. And now I'm going to separate this again into 2 fractions, just like we did when we went into it. It was 2 fractions. We put them together. Now I'm going to pull them back apart and say that's 4 over 4 times 1/5. And you're saying, why are you doing all this crazy stuff, Miss Stevens? I already know this. I just want you to see. So 4 over 4 is the same thing as what? 1. Good. And if I take 1 times 1/5, of course, when you take 1 times any number, the answer is going to be that number. So my answer is going to be 1/5. So we know that 1/4 times 4/5 is 1/5. And there's a shorter way to do that, but I want you to see why. So let's go back to this step right here. If I know that I can change the order of this factor and get 4 over 4 is 1 times 1/5, then that's where I'm dividing out common factors. It's the same thing, but it's because that this is 4 over 4 is 1, and then I just have 1/5 left over. It's like canceling out common factors. So I can cancel out those common factors right here. What I'm doing is dividing out a 4 here, and I get 1. I'm dividing out a 4 in the denominator, and I actually get 1. So now if I multiply straight across, I get 1 times 1 is 1, and 1 times 5 is 5. So I could go straight from this step over to here. And I'll let you do this. This part, I just want you to see why we're doing what we do. You can skip this step. And some people say, well, Ms. Stevens, can't I just go straight from here to here? Absolutely, you can. So we can now skip even this step. Because I know that these two factors up here are multiplied together and these two factors down in the denominator are multiplied together. Then this factor of 4, I see it in the numerator and I see it in the denominator. I can go ahead and divide it out right there. So now I can say 1 times 1 is 1. 1 times 5 is 5. So I can go straight from this problem to the answer. That's okay. All right, let's move on to example number 4. Okay, example number 4, this time I've got a whole number. Well, what do I do with that whole number? Put it over 1, you're exactly right. So that's the same thing as negative 15 over 1 times 2/3. Now, is there a common factor with 15 and 3? Yes, there is. So I could rewrite that as negative 5 times 3 times 2. Okay, this is the negative 15, and I'm just putting them together. And then I could say that that's 1 times 3. So now I can divide out the 3's. And I'm left with just negative 5 times 2 is negative 10. 1 times 1 is 1. And that's negative 10 over 1, which is negative 10. I could do the same thing right here. I could divide the factor of 3 out in the denominator, just like this. I'm dividing the 3 out. I could divide a 3 out in the numerator, and I get negative 15 divided by negative 3 is negative 5. So negative 5 times the 2 is negative 10, actually right here. And the 1 times the 1 is the 1, and that's the same thing as negative 10. And I have people say, well, Ms. Stevens, couldn't I just put that negative 15 over 1 times 2 over 3 and say that negative 15 times 2 is negative 30 over 3? Absolutely, but you got to reduce it. What I'm doing here is going ahead and reducing it here, dividing out the 3, or reducing it here in whichever step I want before I multiply it all back in. Because when you get these great big numbers when you multiply, sometimes it's hard to see that common factor of 3 that we're dividing out. So it's just a shortcut. But negative 30 divided by negative 3 is negative 10. 3 divided by 3 is 1. I'm still going to get my answer of negative 10. Up here, I could have multiplied 4 times 1 is 4. 4 times 5 is 20. And then see there's a common factor of 4 and divide it out. But now we have the ability to know that I could actually cancel them out or divide out those common factors before I multiply in to make it a little easier. Okay, our last example is 2 1/2 times 4/15. Uh-oh, what do I do with a mixed fraction? Well, remember last quarter we learned how to change mixed fractions into improper fractions. You've actually been doing that for a few years. So we're going to change this into an improper fraction, then multiply it just like the fractions above. So remember, we take the denominator times the whole number. So that's going to be 4. And then 4 plus 1, I add the 4 with the 1, and I end up with 5/2. So if I have 2 candy bars and a half a candy bar, that's the same thing as having a bunch of halves, 5 pieces, okay, and they're all halves of pieces. Okay, so now I'm taking 5 halves, that's a times, it's a dot, times 4/15. So now I'm ready to multiply. Well, Is there anything I can divide out? Is there anything I can divide out from the numerators to the denominators? Yes, I've got a factor of 5 here, I've got a factor of 5 here. So I can divide out a 5 here, and I get 1. I can divide out the 5 here, and I get 3. I also have a factor of 2 that I can divide out. I can divide out a 2 there and get 1. Divide this 2 out from the 4 and end up with 2. Now I'm ready to multiply straight across. 1 times 2 is 2, and 1 times 3 is 3. So my answer is 2/3. Now you're also going to do a show me video on dividing fractions. I do a few examples on your paper that you were working these problems, your notes. It's on the back of that paper. And the show me video is on my website. Just click on it next. And you're going to look at dividing fractions. If you want to take a break, you can, and then come back and look at dividing. Thank you.